Hello, algebra students. We're going to take a look at 9.4 and 9.5. This is solving systems with the elimination method. So there is a third way to solve systems known as elimination. And in this method, you kind of line up the coefficients. And you add the equations together and eliminate a variable. So if we look at this example 1 in systems here, and in this, the variables are already lined up. The x's are, they're arranged, the equations are arranged in the same form. If they weren't, we would have to kind of rearrange them, transform them, so that the variables would be lined up. But these are conveniently lined up as our first example. So what we'd like to do is add these equations together. So we're just going to draw a little line under there, and we're literally going to add the equations together. And of course, you just want to add like terms, and they have to be on the same side of the equal sign. But when we add 5x and 3x, that gives us 8x. And what you'll notice is that when you add your y terms, they cancel, and that would be 0. And so they go away. And then we have 12 plus 4, which is 16. And so you can see we have eliminated a variable. The next step would be to solve for x. And so we just divide both sides by 8, and we realize that x is equal to 2. And so we have that x is equal to 2. And we want to substitute that value of x back into either equation. It doesn't really matter which one. So I will usually either go with the first one, or you just go with whatever one you think is going to be easier. If we take that first equation and we substitute the x in, and then solve for y. And so just kind of continue my work here, solving for y. I get negative y is equal to 2, and so y has to be equal to negative 2. And so I have gotten an ordered pair of x as 2 and y as negative 2. Now, of course, we want to check our answers. So we know that we can check by taking the original equation, because we can always check an ordered pair in an original equation, by plugging it in to that original equation and making sure it comes out equal on both sides. And so that works in the first equation. But of course, we want to make sure that we're solving a system, so we want to check it in the second equation as well. And so we're going to plug in our 2 and negative 2. And we can see that that works in the second equation as well. So our ordered pair of 2, negative 2 is correct. So in example 2, we want to solve the system by elimination. So you do want to add the equations together. So again, the variables are lined up and on the same side of the equal sign, which is convenient for the example. If they weren't, we would have to rearrange the equations, transform them to get the variables lined up. We have matching terms of 6c. Now the problem with that is we can't add them and have them go away, because they're not. 6c and 6c are the same, not opposites. So we have to think about, what could we do transformation-wise to make that one of the 6c's eliminate, which is probably our easiest thing, because those are already matching coefficients. So we just want to make them opposites. Well, you can transform one of the equations by multiplying through by negative 1. So if I multiply through by negative 1, that's just going to change the sign of everything in that equation. At which point, I have opposites, and I can add the two equations together to eliminate the c term. and I get 9D is equal to negative 27. I would solve for D. I get D is equal to negative 3. Then I do need to plug that back in to one of the equations. Again, it doesn't matter which one, you just go to one of them. I just usually am going to pick the first one if it looks reasonable. And I'm going to plug in that negative 3 for D. And solve for C. And I find that C is 1. So now I've got an ordered pair there, a couple of things there. That ordered pair isn't XY, so we've got to look at what order we put that in. Usually when we're putting it in an ordered pair format, alphabetical order prevails. So C comes before D, so that's like our X. And our D is negative 3. As we're plugging it in to check it, doesn't really matter because we have the letters to go by. So I am going to just take that first equation. So this is my check. And I'm going to say 6C plus 7D equals negative 15. And plugging in my two variables that I'm hoping is my solution. And that does work in the first equation. And then I try it in the second equation. Because when we're solving a system, we need to make sure that it works in both. And you can see that it does, and so our solution is correct. When we look at the next example, we can see that we don't have any matching coefficients. Again, the variables are conveniently lined up for us, and the terms are on the same side of the equal sign, but we don't have opposite terms, and we don't have matching terms that we can just multiply through by negative 1. So we'd like you to think about how can I transform an equation that I would create opposite terms that would eliminate. So I would love for you to pause the video and try to work this out yourself as a U-turn, a your turn, and then restart the video to check when I'll be working through it. So to transform this equation, it's not the only way to do it. So if you've done, if you paused and you tried it on your own, you may have tried something else, and that's okay. But one way to transform this equation is to simply multiply the first equation by 2. And so I get, I'm going to just rewrite my um, 3x equation so I can line things up. And if I multiply that first equation by 2, then I get 8x minus 10y equal to 46. And so what that does for me is create opposite terms that I can add together. And that's going to give me 11x is equal to 77, which then I can solve for x. And get x is equal to 7. Now I would plug that back in to the original equation to solve for y. And as they do that, I get y is equal to 1. Now I do want to check, so you want to plug those back in and make sure that your ordered pair of 7, 1 works in both equations. All right, so the next one is a challenge, and Trulia, your turn. I'd like you to solve that system by elimination and bring it into class.